Every year, governments, energy companies, and industrial developers announce billions of dollars worth of new hydrogen projects. The headlines promise cleaner industries, lower emissions, and a future powered by renewable hydrogen. Gigawatt-scale electrolyzers are unveiled. Engineering firms release ambitious designs, and investors celebrate what appears to be the beginning of a new industrial revolution. Yet behind the excitement lies a much quieter reality. Many of these projects will never produce a single kilogram of hydrogen. They won't fail because engineers cannot build them. They won't fail because electrolyzers stop working. Many will never even reach full construction. Hidden behind every successful hydrogen project is something most people never see: a commercial system that determines whether the engineering will ever become reality. Across Europe, North America, Australia, the Middle East, Asia, and Africa, hundreds of hydrogen projects have been announced. Renewable energy developers, utilities, steel manufacturers, fertilizer companies, ports, and governments are all investing in the hydrogen economy. On maps, these projects appear as a rapidly expanding global network of future production facilities. It creates the impression that the hydrogen transition is moving quickly, but announcements are only the beginning of a much longer journey. Between an announcement and an operating hydrogen plant lies a complex sequence of engineering, financing, procurement, construction, and commercial agreements. Every one of those stages depends on confidence that the project will generate reliable income for years to come. This is where the story changes. Around the world, many announced hydrogen projects slow down, are postponed, or quietly disappear from development pipelines. Construction equipment never arrives. Equipment orders remain unsigned. Financing packages remain incomplete. Engineers may have completed detailed designs. Environmental approvals may already exist. Renewable electricity may even be available. Yet the project remains frozen. The obstacle is rarely the technology itself. More often, the missing piece is commercial certainty. Investors are not simply funding hydrogen production, they are funding future revenue. Without confidence that hydrogen will actually be sold, even the most advanced engineering project becomes a financial risk. So, why do technically sound hydrogen projects struggle to move forward? Why can a project with proven technology, experienced engineers, renewable electricity, and government support still fail to reach construction? The answer is surprisingly simple. Before banks finance billions of dollars in infrastructure, they want to know one thing: who is going to buy the hydrogen? That single question leads us to one of the least understood, but most important, documents in the entire hydrogen industry. It is not an engineering drawing, a process flow diagram, or an equipment specification. It is the offtake agreement, the hidden contract that often determines whether a hydrogen project is built or remains only an announcement. The hidden system behind every successful hydrogen project is the offtake agreement. At its simplest, an offtake agreement is a legally binding contract between the hydrogen producer and the customer who will purchase that hydrogen. But in reality, it is much more than a sales contract. It is the commercial foundation upon which the entire project is built. Every electrolyzer, compressor, storage tank, pipeline, loading terminal, and power connection ultimately depends on this agreement. Before billions of dollars are committed to construction, developers, investors, lenders, and suppliers all need confidence that the hydrogen leaving the plant already has a destination. The contract transforms future demand into contractual demand, giving the project a commercial purpose long before the first foundation is poured. An offtake agreement is, in essence, a long-term promise to buy. Instead of hoping customers will appear after production begins, the producer secures commitments before construction starts. The agreement defines how much hydrogen will be purchased, how often deliveries will occur, quality specifications, delivery locations, pricing mechanisms, and the responsibilities of both parties. This creates a predictable relationship between production and consumption. The hydrogen plant is no longer operating in isolation. It becomes directly connected to an industrial customer that depends on its output. This relationship is what transforms engineering plans into a commercially viable business. Now imagine removing that customer from the system. The electrolyzers can still produce hydrogen. Storage tanks can still be filled. Pipelines can still transport the gas. But if nobody has committed to purchasing the product, the hydrogen has nowhere to go. The engineering systems continue to exist, yet the business model collapses. Expensive infrastructure quickly becomes idle assets rather than productive investments. This is why hydrogen projects are never judged solely on technical capability. Successful engineering only creates value when it is connected to reliable industrial demand. Without a committed buyer, there is no predictable revenue. And without predictable revenue, financial models become extremely uncertain. Every hydrogen project begins with detailed forecasts showing future cash flow over many years. Those forecasts determine whether lenders believe loans can be repaid and whether investors can recover their capital. When the customer disappears, those revenue projections disappear as well. Suddenly, the project is no longer viewed as a reliable investment. It becomes a speculative venture. This is why the absence of an offtake agreement immediately affects every financial decision surrounding the project. Banks often appear to finance engineering projects, but in reality, they finance predictable cash flow. Before approving billions of dollars for construction, lenders carefully examine the project's commercial structure. Their first question is remarkably straightforward. Who is going to buy the hydrogen? They are not evaluating only electrolyzer efficiency or renewable electricity availability. They want evidence that the hydrogen produced by the facility already has committed customers capable of paying for it over many years. Without that confidence, financing becomes significantly more difficult, regardless of how advanced the engineering may be. The answer usually comes from heavy industry. Steel manufacturers require hydrogen to reduce iron ore while lowering carbon emissions. Fertilizer producers depend on hydrogen to manufacture ammonia. Refineries already consume enormous quantities of hydrogen during fuel processing. Future demand may also come from shipping, aviation, chemicals, synthetic fuels, and power generation. Each customer represents more than a sales opportunity. They become part of the hydrogen project's long-term operating system. Once demand is secured through contracts, developers can size equipment, design infrastructure, and plan operations around known customer requirements rather than uncertain future markets. A strong offtake agreement fundamentally changes how investors and lenders evaluate the project. Instead of seeing uncertain future sales, they now see committed revenue supported by legally enforceable contracts. That reduces uncertainty across the entire investment. Developers gain easier access to capital. Equipment suppliers gain confidence that purchase orders will proceed. Engineering, procurement, and construction contractors can begin detailed planning with greater certainty. In many cases, the offtake agreement becomes one of the most valuable assets the developer possesses because it unlocks the financing required to move from planning into construction. Ultimately, the agreement reduces risk throughout the hydrogen value chain. Revenue becomes more predictable. Financing becomes more accessible. Investors gain confidence. Suppliers commit resources earlier. Customers secure reliable long-term hydrogen supply. Even engineering decisions become easier because production capacity can now be matched to known demand rather than estimates. What appears to be a simple commercial document is actually a hidden engineering system connecting finance, infrastructure, operations, and industrial customers into one coordinated project. That is why the offtake agreement is far more than paperwork. It is one of the key mechanisms that allows hydrogen projects to move from concept to reality. Not every offtake agreement gives investors the same level of confidence. Financial institutions look beyond the existence of a contract and examine whether it can support a multi-billion-dollar infrastructure investment. The first characteristic they evaluate is its duration. Hydrogen projects are capital-intensive assets designed to operate for decades. Electrolyzers, compressors, storage facilities, substations, pipelines, and loading terminals all require substantial upfront investment. Recovering that investment demands stable revenue over a long period. This is why bankable hydrogen projects typically rely on long-term purchase agreements lasting 10, 15, or even 20 years. Duration alone is not enough. The agreement must clearly define how much hydrogen will be delivered throughout the contract period. Every engineering decision depends on that number. Electrolyzer capacity, compressor sizing, storage requirements, pipelines, truck loading systems, and export terminals are all designed around committed demand. Firm purchase volumes allow engineers to optimize the facility while giving investors confidence that future production is supported by measurable revenue rather than assumptions. A successful hydrogen project also requires a pricing structure that works for both parties. Developers must recover capital investment, electricity costs, maintenance expenses, and operating costs over many years. At the same time, industrial customers need hydrogen prices that allow them to remain competitive. Some agreements use fixed prices while others include inflation adjustments or market-based pricing formulas. The goal is not simply to maximize revenue, but to create a commercially sustainable relationship capable of surviving changing market conditions throughout the life of the project. The financial strength of the buyer is equally important. A contract has little value if the customer cannot meet its payment obligations. Banks therefore evaluate the buyer as carefully as they evaluate the producer. They examine financial statements, credit ratings, business history, and long-term stability. A financially strong steel producer, refinery, fertilizer company, or industrial manufacturer provides confidence that contracted revenue will actually be received. In many projects, the customer's creditworthiness becomes just as important as the engineering itself. Reliable delivery is another requirement of a bankable agreement. Producing hydrogen is only one part of the system. The product must also be compressed, stored, transported, and delivered safely according to agreed schedules. Storage facilities, pipelines, truck loading stations, shipping terminals, and logistics operators all become part of the commercial commitment. Delivery quality, purity, pressure, and operating responsibilities must be clearly defined so industrial customers can confidently integrate hydrogen into their manufacturing processes. Many large industrial contracts include a take-or-pay provision. Under this arrangement, the customer agrees to pay for contracted hydrogen volumes, even if actual consumption temporarily falls below expectations. This significantly improves revenue certainty for the producer. Investors know temporary fluctuations in demand are less likely to threaten project income, while lenders gain greater confidence that loans can continue to be serviced. Take-or-pay provisions are one of the strongest indicators that an offtake agreement is commercially bankable. Every successful agreement also balances risk between producer and customer. Electricity prices may change. Equipment performance may vary. Supply chains may be disrupted. Transportation delays or force majeure events can interrupt operations. Rather than placing every risk on one organization, bankable agreements clearly define responsibilities before construction begins. Balanced risk allocation builds trust between both parties, while providing lenders with confidence that commercial disputes are less likely to threaten the long-term success of the project. One of the largest future markets for hydrogen is the steel industry. Green hydrogen can replace coal as the reducing agent in direct reduced iron production, dramatically lowering carbon emissions. But steel manufacturers cannot redesign billion-dollar facilities without confidence that hydrogen will remain available for decades. Long-term offtake agreements provide that certainty. They allow hydrogen developers to build production plants while giving steel producers confidence to invest in cleaner manufacturing. The agreement links two major industrial investments into one coordinated system. Another clear example is ammonia production. Hydrogen is an essential feedstock for manufacturing ammonia, which in turn is used to produce fertilizers that support global food production. Because ammonia plants operate continuously, they require dependable hydrogen supplies throughout the year. Long-term offtake agreements secure reliable deliveries for fertilizer producers while providing hydrogen developers with predictable revenue. This commercial relationship enables both industries to invest confidently in lower carbon production. Oil refineries already consume enormous quantities of hydrogen every day for hydrotreating and hydrocracking. As refineries pursue lower carbon operations, cleaner hydrogen becomes increasingly attractive. However, refinery processes require uninterrupted supply. A bankable offtake agreement guarantees agreed volumes, quality, and delivery schedules, while providing developers with the long-term revenue needed to finance dedicated hydrogen production facilities. The agreement connects existing industrial demand with new hydrogen infrastructure. Not all contracts inspire investor confidence. A weak agreement may contain uncertain purchase volumes, vague pricing, short contract durations, or financially weak buyers. A bankable agreement clearly defines long-term commitments, fixed or transparent pricing mechanisms, committed volumes, reliable delivery obligations, balanced risk allocation, and legally enforceable responsibilities between financially credible organizations. That difference often determines whether financing is approved. The contract itself becomes a critical piece of project infrastructure. By now, the hidden system becomes clear. Hydrogen production is not simply about generating clean molecules. It is an interconnected chain of engineering, infrastructure, finance, logistics, and industrial demand. Renewable electricity powers the electrolyzers. Electrolyzers produce hydrogen. Compressors, storage systems, pipelines, trucks, and terminals move the product. Industrial customers consume it. Banks finance the infrastructure. Investors provide capital. Connecting every part of that chain is the offtake agreement. Without it, each component remains isolated. With it, the entire hydrogen value chain operates as one coordinated industrial system. When people picture a hydrogen project, they usually imagine electrolyzers, storage tanks, pipelines, wind farms, or solar plants. Those assets are certainly essential, but they represent only the visible side of the system. Hidden beneath the engineering is a commercial framework that transforms ideas into operating infrastructure. A bankable offtake agreement converts expected demand into committed revenue into financing, financing into construction, and construction into long-term hydrogen production. It aligns engineers, investors, lenders, suppliers, logistics providers, and industrial customers around a common objective. In many ways, the most important component of a successful hydrogen project is not a machine at all. It is the agreement that gives every machine a purpose. Understanding that hidden connection allows us to see hydrogen projects not as isolated technologies, but as complete industrial systems. That is the system behind the system, and one of the most important lessons in building the hydrogen economy.